Hello, and thank you for coming to my talk. So tone change refers to the diachronic development of tone after tonogenesis and is poorly understood in comparison to what we know about segmental change. In tone change research, the focus has been on splits and mergers, but phonetic tone change, where the phonetic shape of the tone changes over time, is not well studied. So there's little research to evaluate if certain tone changes are more likely than others. This makes the comparative method difficult to apply to tone change. There's often a feeling like anything can happen when it comes to phonetic tone change. So one approach to this problem is to start small, comparing tone values across only closely related lex or dialects where the differences are not so great, and you can see intermediate stages along a certain change pathway. And there is a growing body of acoustic dialect studies on tone languages in Asia. However, without reconstructing the tone system of the proto-language, the tone change pathway is still unclear, because if you don't know the starting point, then you don't know the direction of the pathway. For example, if you saw tone plots like this, comparing tone across 4 different dialects, where the historic tone category is plotted with the same color across the dialects, it's easy to identify what look like intermediate stages along a pathway, but the data itself is not able to tell you what direction the change was proceeding in. So in other words, did the falling tone in purple become gradually higher or lower? If you don't know what the archaic or conservative phonetic value of the tone was, then the direction is ambiguous. So that brings us to this study, where I will be looking at acoustic dialect data within 2 language clusters in Mui or Loloish branch of Tibeto-Burman. And for this talk, I'm going to focus on Lalo. So I will first reconstruct the phonetic values of the tone system, and then after establishing that starting point, I will trace the tone change pathways. And in both clusters, we'll see a high rising tone becoming gradually lower and a low falling tone becoming gradually higher. To conclude, I'll discuss why I think these changes are phonetically motivated. So the Mui or Loloish languages belong to southeastern Tibeto-Burman, shown in green on the map. They're mostly located in Yunnan province in southwest China. And Mui languages are fairly typical of the Sinosphere. They're analytic type morphology. They usually have omnisyllabic tone, where each syllable / morpheme is specified for lexical tone. The tone inventories tend to be medium-sized with 3 to 8 tone categories. And many Mui languages have a phonation contrast between tense and lax phonation that crosscuts the tone system. So here's the reconstructed tone system for Proto-Mui based on Bradley 1977. Proto-Mui had a 3+1 tone system where there was a 3-way tonal contrast in syllables that ended with a vowel or nasal, so and a distinctive phonation associated with each tone category. So 1 high with modal phonation, 2 low and breathy, 3 mid and creaky. And it's not clear when the shift happened from a more phonation-based, which was probably at the Proto-Mui Burmese stage, shifting over to a more pitch-based system later. But when that happened is not clear. The 4th category was stop final. And Matisoff 1972 reconstructs a tone split in 4 according to the prefix, voicing of the prefix or initial type. So higher, that's why we call it tone H, after voiceless initials or voiceless prefixes, and lower, or tone L, after voiced initials and or voiced prefixes. So skeptics would say, how can you know the tone values, the phonetic values of reconstructed tone categories? Well, We don't have a time machine, so we can't know for certain. But in this case, there are good reasons to think that these reconstructed tone values are close to what Proto-Mui actually sounded like. Let me explain. So this map of Yunnan province and surrounding areas shows the Mui languages that have a conservative tone system in pink and those that show splits or mergers or both. So conservative tone systems are those that show neither split nor merger, nothing, which is rare for this part of the world. And these conservative languages belong to two separate sub-branches in Hui, Central Hui and Southern Hui. The respective ancestor groups of these sub-branches probably went their separate ways over 1,000 years ago. And there's little evidence to suggest that Central and Southern Hui should be subgrouped together. Yet in both sub-branches, the tone values match each other for each tone category. 1 high, 2 low, 3 mid, H mid and tense, low, L, tone L, low and tense. Now, it's unlikely that the conservative languages in these two different sub-branches would have innovated the same exact tone values as each other. Instead, it's more likely that these conservative languages are retaining an older system. So the geographic distribution and the tonally conservative nature of these languages support the reconstruction of Proto-Mui tone values. Especially for the Laloid cluster, these are dialects of Lalo, spoken in Western Yunnan, the starting point is easy to establish because many Lalo leks are conservative, have this conservative type of tone system, like the Central Lalo spoken in Laba village, shown here, which basically retains the Proto-Mui system of 1 high in red, 2 low in blue, 3 mid in gray, tone H mid and tense with the gray dotted line, and tone L low and tense, the purple dotted line. Now within the Lalo cluster, there's quite a bit of diversity in tone. There are tonally innovative leks in the eastern region that show a tone split in tone 1, and the highly innovative leks in the west that show both the tone 1 split and a phonetic tone change of tone L. So let's take a look at how this plays out across this geographic region. So figure 1 lines up the Lalo leks on a scale from tonally conservative on the left, so this is the Laba system with basically no change, to the innovative languages in Central East and Eastern regions, and highly innovative Western Lalo leks. So having a clear starting point enables us to interpret the direction of the tone change pathway. It's clearly from the left, no change, to the right, where you see in the west split and phonetic tone change and a conditioned merger. So let's look at tone 1 first and trace its change pathway. So tone 1, conservative value is high level, but in syllables with voiced initial consonants, the red line, a rising tone split off from high level and became contrastive after a merger in the initials. In the West, this starting in Central East and Eastern, in the West, the new contrastive rising tone has lowered and flattened with slightly different conditioning in Shuizhuping and Dutian. This is shown with the brown line. Now let's look at tone L, the purple line. So tone L's conservative value is low and tense, as we see in Laba, but mid-falling in the eastern lect of Gyaltsao, high-falling in Ilu, high-rising falling in Shuizhuping, and high-rising in Dutian. And these are not, this change is not conditioned by syllable initial consonants. It's just the whole tone category is moving. Now the tone variation in the Western leks appears to be a case of peak sliding, a tone change mechanism identified by Pityaporn 2007 to describe the rightward sliding or the delay of the F0 peak. So we can see the peak at the beginning of the syllable in Ilu, in the middle of the syllable in Shuizhuping, and at the end of the syllable in Dutian. Now, as tone L enters the upper pitch range, the formerly high-level tone 1 variant, shown in orange and in yellow in Shuijuping and Dutian, it lowers from high to mid-high. And this causes a merger in the Western Lex. It merges with tone H. So these two changes appear to be interrelated. I mean, tone L going up into the upper pitch range and tone 1 high level moving down to mid-high. This is why I labeled this as a tone change shift, although the chronological ordering of these two changes is not clear. So to sum up, we see a rising tone emerging from the upper pitch range, becoming gradually lower and flatter. And we see a low falling tone become gradually higher. Once it enters the upper pitch range, its peak slides to the right. Another way to look at tone change shift in Western Lalo is to depict it as movements through tonal acoustic space, as suggested by Shen 2016. So the y-axis is F0 onset height, with the 0 representing mid, and the x-axis is slope. So positive slope on the right, meaning a rising tone, and negative slope on the left, meaning a falling tone. So what has happened in Western Lalo is that tone 1 in syllables with voiced and aspirated initials move to the right and down, becoming low rising, while tone L moves up from low falling to high falling, then to high rising, and tone 1 in preglottalized and with preglottalized sonorants and voiceless unaspirated syllables moves down to merge with H. So I'd like you to notice what looks like parallel changes, but in opposite directions. So a tone in the upper pitch range moving down on the right, and a tone in the lower pitch range moving up on the left. We'll just briefly look at the Limi language of the Loloid cluster, which is located in central Yunnan. So in Limi, we see the purple line, which is a conditioned merger of tone 2, tone L, historically low tones, has moved all the way up to be the highest tone. And tone 1 in voiced syllables, the red line, has again become a mid-rising tone. Tone 1 in syllables with voiceless initials, the orange line, is again a mid-high tone. So something very similar to what happened in Western Lalo has happened independently in Limi. Limi and West Lalo speakers have never been in contact with each other. Instead, I think the reason behind the similarities is that the same phonetic biases are at play in the tone changes. So to summarize the findings, for a tone in the upper pitch range, the F0 onset has lowered, resulting in high level becoming mid-rising, becoming low rising. For a tone in the lower pitch range, the F0 onset has raised, resulting in low falling, becoming mid falling, becoming high falling. After the F0 onset reaches a certain point, for example, the formerly high F0 onset enters the lower pitch range, there are subsequent changes to the contour shape. So a low rising tone flattens, and a high falling tone becomes rising falling, becomes rising, peak sliding, or in Limi, a high falling tone has become high level. So the changes that I just described that we observed in this study are similar to developments in other non-related languages. So in a review of tone change studies, Yang and Xu 2019 found that there were many languages that showed at least one of the changes seen in Laloid and Loloid. And some languages, such as Bangkok Thai, Miancheng Chinese, and Donggan Chinese, show both falling tone becoming higher and rising tone becoming lower. In contrast, no languages showed a change in the opposite direction. For example, a low rising tone becoming mid-rising or a high falling tone becoming mid-falling. That was not reported in this review. And the fact that the changes seen in this study happen commonly in non-related tone languages suggests there is some phonetic motivation behind them. So what might that be? Well, timing constraints are key to tone production because The approximation of a tone target has to be synchronized with its segmental host, and variation in that alignment opens the door to phonetic tone change. And many tonologists have noticed that compared to the oral articulators, the larynx is a little bit slow. As Hyman and Shu noted in 1974, phonetically, the laryngeal adjustments required to regulate pitch changes seem to require more time than the articulatory adjustments required to produce successive segments. Now, Patayaporn was the first to link this phonetic bias to tone change, specifically in the case of peak sliding. Because F0 peaks tend to be delayed rather than early, tone peaks have a greater tendency to shift rightwards rather than leftwards. What I'm suggesting is that laryngeal slowness may also be a root cause contributing to high rising tones lowering and low falling tones raising. Because one of the consequences of laryngeal slowness is carryover effects. This is where a preceding tone has a large assimilatory effect on a following tone's F0 onset. It's a very common type of contextual variation for tone. And we're going to compare different carryover effects on a high tone versus a low tone. So figure 3 shows the F0 tracks for 2 syllable sequences in Mandarin. So the top right panel is tone 1, a high level tone, and the bottom right is tone 3, a low falling or sometimes a dipping tone. So let's look at what happens to a high level tone when it follows another high level tone. So this is in a congruent tonal environment. Nothing happens. The high tone target is immediately realized. There's no innovative variant generated that's different from the canonical tone value. So no potential change is seen in the congruent environment. But how about if it follows any other tone? So in a conflicting environment, where the F0 offset of the preceding tone is not already at the same level as the tone target of the following tone. Well, the F0 onset at the F0 onset is lower. The high tone is realized with a rising F0 track. If you look at what happens to the low tone in Mandarin, when it follows a high or rising tone, the onset is considerably higher. So it's no longer a low tone, it's more like a mid-falling tone or a high-falling tone. So for tones in the upper pitch range, the F0 onset will either retain the conservative tone value or it will be lowered, which opens the door to sound change. For tones in the lower pitch range, the opposite effect is seen. F0 onset will either stay low or be raised. So the variation generated by carryover effects is non-random and asymmetrical. And this is a phonetic bias that shapes the directionality of phonetic tone change. So in summary, after establishing the starting point of the prototone system for the Laloid and Loloid clusters, I traced the tone change pathways and found a similar tone change pattern in both, namely the F0 onset lowering in high tones but raising in low tones. And this result is in line with the developments seen in other non-related languages and appears to be rooted in articulatory constraints on tone production, specifically laryngeal inertia leading to carryover effects on F0 onset that generate the allotonic variation patterns that feed into tone change. So to conclude, wouldn't it be neat if we had more examples or counterexamples of phonetic tone change that we could refer to when we're doing tonal reconstruction, for example? So I'd like to end by asking you what you have seen in the language varieties you have been working on. Thank you.